would be 1 over, we want it on the integral from 0 to 3. Then 0 to 3. Then my function f of x, which is x squared sine x dx. Okay, then remember, calculator practice, you're typing that in. Do you remember how to pull up the fraction? Alpha y equals 1 over 3 minus 0. Math 9, integral 0 to 3. And then your function alpha trace y1 dx. Okay, just like that. And then you're just pushing enter on it. If your number doesn't come out to be that, you're probably in degree mode. You should be in radian mode. Huh? Math 9. Okay, and I'll just type the whole thing in at once. Alpha trace. And then dx at the end. Good. So it's 1.925. Good? Huh? Yeah. Are you asking how to pull up the fraction bar? So, oh, I see. Okay, if it came out as a fraction here, hit math, and then go down to decimal, and then push enter on it, and it'll convert it to a decimal for you. Did that work? Okay. But since mine was already a decimal, obviously it's that way. Okay? Now, look at part B. It says, when does f of x equal the average value? Well, then all that I need to do is set x squared sine x equal to 1.925 on the interval from 0 to 3. Now, let me remind you that whatever the average is, there's a theorem that promises that that's going to happen, that it's going to equal that number. So all that I have to do is let this be my y1, let this be my y2, and then I can solve for graphing by just finding where they cross each other. Okay? So I'm going back into my calculator. My y equals is already in there. I'm going to make my y2 1.925. And then what else could I adjust so that my graph isn't so big? Well, yeah, but I'm just going to go, instead of doing the zoom, I'm going to just go 0 to 3. So I'm going to push window here. I'm going to let my min be 0, my max be 3. And then y is, it doesn't matter. You can change it if you want to. I'm just going to leave it. Okay? So, here goes my sine, my x squared sine x. Okay, there goes my cosine. Now, my flat line. What do you notice about my average? Where is it?
I can't see anything.
It's perfectly the average. Half the graph is below. Half the graph is, it's an average. It's the average y value. How many times do I cross it on this interval? Twice. Okay? So, find where they cross. Go ahead and do it on your calculator. You don't see anything? Oh, you do. So, we're going to do second trace. Option 5 is intersect. Enter, and then for guess, I'm going to put like 1.3. Okay, it crossed at 1.3979. That's the first intersection. And then let's find the other one, second trace. Option 5, enter, and then I'll guess like 2.8. Okay, it's 2.9126. Also, remember, you can also, on the guess, just kind of arrow close to the one that you want. That works too. Okay? Other thing I'm going to do here, just in case you study this at some point, wishful thinking, okay, is that there's your graph. This is your average. And remember, like I said, if it's an average, think about it, about half the numbers are going to be below, about half the numbers are going to be above, because it's like the median or whatever, whatever. It's not the median, it's the average, but it's the mean, okay? Got it? Yes. It was this number, the average that I got, because I want to know when my f of x equals the average I just got. So I let my y2 be the 1.925, and then I just found where they cross. Good? Okay, turn the page. Okay, so take a look at number 27. Okay, go ahead and type your equation in for me. So it's 6 over x plus 1. So I'm going to pull up my fraction bar, 6 over x plus 1. Okay, then it says the particle's position at 3 seconds is x of 3 equals 7. Part A and part B both say average. Here I want the average velocity. Here I want the average acceleration. You have two averages. You have average rate of change, which you've been doing forever. Now you have average value, the 1 over b minus a. Which one is part A? A rock or average value? Value. Here's why. Here's how you know. What is my equation up here? Velocity. What do I want the average of? Velocity. Those are the same thing. So it's not an average slope, it's an average y value. Because this is velocity, then I want the average value. So I'm going to put here, average value, because same units. And that tells me that when I go to my calculator in a second, I'm going to do 1 over b minus a, which is 4 minus 0, integral 0 to 4, and then of my function v of t, which is the 6 over t plus 1. Now, I don't want to rewrite the equation, so I'm just going to put v of t, but you could also sub in 6 over t plus 1 and put that there. Okay? Now, we'll type those in a second. Let's do part B, though. How do I know that part B is a rock? Because this is velocity, this is acceleration. What is acceleration for velocity? The rate of change, the slope. Very good. So this is going to be a rock. Okay, and I'm going to put because acceleration is the slope of velocity. And remember that slope and rate of change are the same thing. Okay? And then what would I do for a rock? I'd do v of 4, v of 0, 4 minus 0. Okay, now let's practice typing that into the calculator. Okay, I already have, as you can see, my equation typed in. So I'm going to do 1 over 4 minus 0, math 9, 0 to 4, function y1 dx, just like that. Okay, if you don't know how to do that, let's work it out now so that tomorrow you're not struggling on this part. You're just punching stuff in. Okay, math 9 for the integral. Alpha trace for the y1. Everybody get 2.414? Okay. Now let's do the a rock. Open up your fraction bar. Alpha trace at 4 minus alpha trace at 0 over 4 minus 0. Okay, double check. If you don't get that number, that means you messed something up.
Wait, how? Is that right? Yeah.
Is anything else getting in there? Oh, it's a plus 1. That's why this is a plus. You just went through. And the reason why is if it was a plus 1 or a minus 1, you would have had an asymptote, and you're trying to tell the calculator to integrate the area under an asymptote. Yeah. I just look at it and do after. Yes. Okay, so y'all try to finish out the next part of that. It's a version B, that's your hint. Okay, so we got 2.414. And then here we got negative 6 over 5. Now, quick question. If this was in, let's say, meters per second, just for fun, what would average velocity still be in? Meters per second. Because what's it the average of? Velocity. What would average acceleration be? Meters per second squared. Okay, so make sure that you understand when I say same units, that means velocity, even if it's average, should still be a regular velocity unit. Okay, what if I want position? Jump down here to fundamental theorem. Okay, remember that the integral from a to b of little f of x is capital F of b minus capital F of a. Okay, that's the regular fundamental theorem. What is version b solved for? F of b equals? Perfect. Okay, so notice that these are the exact same equation. The only difference is that in version B, your f of b is solved by itself. This is typically what you want. F of a is what you have. And then you do the integral from what you have to what you want. So let's use that for part C. When do I want the position? At what time in part C? We want the particle's position at 10. So I want x of 10. When do I have the position? Go back and read the question. It says right here, the particle's position at 3 is x of 3 equals 7. So I know x of 3 plus the integral from what I have to what I want of velocity. Now, let's talk about this little part here real quick. Okay, why is this a velocity? Well, remember, how do I get from little f to capital F? I take the antiderivative. How do I get to position from v? Okay, it's the exact same relationship. This is like capital F if that's a little f. But this is position, that's velocity, but it's the same thing. Okay, now, what is x of 3 we said? 7. And then what am I going to do with this part? Put it in the calculator. So I would do 7 plus, and then I'm going to calculator math 9, 3 to 10 of the function y1 over dx. That's going to tell me how much my position changed. 6.0696. But is that the answer? No, what do I have to remember to add? X of 3, which is a 7. Make sense? Okay, so I want you right now to set up number 28. It's also a version B. They're giving you a velocity equation. They're telling you the position at one time. They're asking you to find the position at another time. So try to set up number 28. See if you can do it. So they give you velocity here. The position of the particle at 4 seconds is 10 units to the right. Find the position of the particle at 12. Okay, try to set it up. When do I want the position? 12. When do I have the position? 4. Plus the integral from what I have to what I want of the velocity equation. Yeah? Then what did we say x of 4 is? 10. Now, quick question. Okay, little hint. If it's 10 to the right, it's 10. What if it had said 10 to the left? Negative 10. Keep that in mind. Okay, so 10 plus, and then this part I'm going to do in my calculator. Okay, so I'm going to do math 9. I'm going 4 to 12. And then my function is square root 2x plus 1. Okay, just like that. Oops, don't put the x there. Okay, just like that. And then once I find that number, I just have to remember to go back and add it to the 10. So if it moved 32.666, I add 10 to that. What's my total? 42.666. Okay, read the next one. Also version B. See if you can set it up. No, because it actually doesn't have units in the question. But it would have been like meters or something like that.
I put 3 and then I put a 7.
Isn't it only supposed to be 3 6 though?
The other. When you round the 4.
Or you could do 6 repeating. Or you could change it to 2/3.
Yeah, I'm gonna do 3.6 because
I'm just 4 6s.
I know that's what I told her, but still, I can't write the third one.
Or you could do 6 6 7.
You can round to the third if you want to. That's allowed. Okay, number 29.
Not in case time.
Okay, when is the temperature that I want? I want the temperature at
5 minutes.
5. When do I know the temperature? At 0. Okay, look, it says the coffee was brewed. That would be at the beginning at time 0. So I know the temperature at 0. Okay, that would be like your starting temp. And then plus the integral from what I have to what I want.
From 0 to 5.
From 0 to 5, 3e negative 2.4t.
Can you not just put R?
You can put R of t if you want to, that's fine. Okay, and so in case you didn't hear Callie's question, it doesn't matter if you call it R of t or if you want to write it in. Either one is fine. Now, when I integrate this in the calculator, okay, let's do it. It's math 9, 0 to 5, negative 3e to the power of negative 0.24x dx. When I type that in, I put my x in the wrong spot. When I type that in, my value comes out to be negative. Why? That's correct that it's negative. What's happening if I integrate degrees whatever per minute? It gives me the number of degrees, right? Number of degrees that what? The coffee cup cools. So it makes sense that it came out negative because my temperature would have gone down. Okay? You probably typed something in wrong. It should be negative 0.24. You have your decimal in the wrong spot. Okay? So I would take my original degrees and then take away the 8.7350 from that. Now, what was the starting degrees? 98. So I'd do 98 minus that, and then that would be my answer. Okay, so I got 89.26, which is answer B. And the reason why, if you're wondering, is because it says right here, at time 0, what was the coffee brewed to? A temperature of 98. So that tells me it should be 98 plus this integral, but since the integral came out negative, that's why I'm minusing it. Okay, one more like that. Read number 30, set up your version B. Okay, so E of T is the rate people enter an amusement park in people per hour. The model is accurate when the park is open from 9 to 23. There are 120 people already in the park. How many people are in the park at noon? Okay, what is the time that I want to know the number of people? P of 12. What is the time? This is tricky. What is the time that they told you? 9. Why is it 9? Okay, they don't open till 9. Now, this is off the AP test, okay, so you have to think about it. Okay, but at midnight, nobody's there. They're not open, right? So you would have to start at 9 when they open, plus the integral from when they open to 12. And then that would be of your function here, which is E of T. Okay, and then I'll do the integral part in my calculator. And then how many people are there in there at 9 for me to go ahead and fill this number in? 120. So I'll do 120 plus, work out that integral, and then just add them together. So it's 9 to 12, 15,600 divided by square minus 24x, oops, plus 160 dx. Okay, did y'all get 2509? So 2,500 or 2,509 people plus the 120 already in there is a total of 2629. 0.654. Now, if this is measuring people, how would I round that? Yeah, I would say that's 2630 people. Okay? Oh, even if it's not developed, it's still a whole
So
person.
what if I put 2629?
Yeah.
Don't round it. So if it's a 0.6, it rounds up. If it's a 0.4, you would round down.
But if it's a person,
Huh? You would just still round. So what it will say, if it's a real AP question, is it will say to the nearest whole number, what is the number of people in the park? And you would round your decimal, whether it's above 5 or above or 4 and below. Is what? This? That is supposed to be like a squiggly equals sign. Like an approximately, yeah. I did kind of make it look weird. But it's an approximately. Q, are you done? Just leave it on my desk. Okay. Did you ask a question, Stephen, to me? Or just... Can you put what? Like put like 3 squiggles? Yeah, that's not a symbol anymore. Now you could always do like, you know how sometimes I'll put like an arrow and then put 2630 people? I think that would be fine too. Yeah, don't do that. Okay. Alright, so we've kind of worked through the whole thing. We want to go back and do anything? Oh, we didn't do any of this? Let's do that. Which one? Okay. It's due when you take your CBA tomorrow. Huh? Yeah. Okay, let's do number 17. Actually, change my mind. Let's do 18. Okay, so first thing, look at your integral. Here's the property that you need to know. Okay, it is already on your notes.
What? Oh my god, they're killing it. I'm behind in so many things. Like I haven't
Okay, so look. If you are going to integrate from A to C, you are allowed to break that integral up into A to B, and then add the integral B to C, and then all together you should have one whole integral, okay? So if I'm doing number 18, what is the biggest number that you see out of all these integrals? Okay, the biggest number is what? What's the smallest number? 1. What's the middle number? 3. So I know how to set it up. It would be 1 to 10 of f of x dx equals 1 to 3 of f of x plus 3 to 10. Okay, remember, that's a rule. That if I want to integrate from 1 to 10, I can stop at 3 and then keep going from 3 to 10, and that's the same. Now, let's use the stuff they gave me to turn this into an equation that I can solve. What is the integral from 1 to 10? Then I'm going to take this and I'm going to put 2 equals. Now, 1 to 3 is what I'm looking for, so I'm going to call that x. And then if the integral from 3 to 10 is what I need, but 10 to 3 is 5, to minus 5. Do we understand why? They gave it to you backwards. And then to solve, I'm just going to add that 5 across. Then the missing integral is 7.
That's it?
Yep.
Is that going to be on the AP test?
Yeah, and it's on your CBA too.
Yeah,
Okay.
same.
Good. Okay, do you want to do 17 real quick?
Yes.
Okay, try to set it up. What's your biggest and smallest number? What's the longest integral? 1 to 4 is longest, and then how are we breaking it up? 1 to 3 plus 3 to 4. Okay, then plug in your numbers. Check to see if anything's backwards. Like if the bigger number's on the bottom, like here, 10's on the bottom, that tells you it's backwards. So I would say from 1 to 4 of f of x is from 1 to 3 f of x plus 3 to 4 f of x. Then it tells me here that 1 to 4 is negative 6. 1 to 3 is 4. And then 3 to 4 is what I want. I'm going to call that x. And then negative 10 is right. I'm going to subtract that 4 across. That tells me that my missing value is negative 10. Good? Okay. 19? Okay, and then we'll turn to the next page. Number 19 is not really hard, but you do have to kind of think about it. Here's the property that you're using. If I have the integral from a to b of f of x plus g of x, that is the same as the integral from a to b of f of x plus the integral from a to b of g of x. Okay, do you remember that? If I have integrals that are added separately, I can combine them. Or if they're combined, I'm allowed to separate them. That's the rule that you're using. Now let's use it. Okay, I want the integral, you can't really see it, but here, of a to b, f of x plus 5. How would I break that down into 2 separate integrals? A to b of f of x plus a to b of 5. Everybody good with that? Okay, if they're added in the same integral, I'm allowed to give them each their own integral. Now, why would I want to do that? Well, the integral a to b f of x was given to me right here. Do you see it? Yeah, they tell me that if I integrate f from a to b, I'm going to get a plus 2b. That's this answer. This answer is a plus 2b. So then what's the only thing left that I have to integrate? 5. What's the integral of 5? 5x. And then what do I do at the endpoints? Plug them in and subtract, right? So if I plug in a b to 5x, what do I have now? 5b. If I plug in an a to 5x, what do I get? 5a. And then what do I do with those two? So it would be 5b minus 5a. And then what am I doing with these two pieces of integral? When I separated them by addition, so I'm just going to combine like terms. My first integral was the a plus 2b. My second integral was a 5b minus 5a. How many b's are there together? 7b. How many a's are there together? Careful. Minus 4a. Okay. Okay, so remember, if you have integrals, you can split them up 2 different ways. Split them up like this, or you can split them up like that. All right, go ahead and turn the page. Let's work through a couple of Riemann sums. 11? Sure. Okay, ready to go back to 11? Okay, so 11 is an average value question. That's your formula. Do you guys want me to just send you a cheat sheet with the formulas on it? Will you make it? Okay. No, okay. Yes. Okay, so if this is my function, I'll do 1 over 5 minus 0. Integral 0 to 5 of f of x, which is 6x squared plus 1 dx. Okay, from there, what is the antiderivative of 6x squared plus 1? Yeah, so x bumps up to a 3. Divide 3 on 6, it's a 2. Plus 1 is a plus x. Then I'm going to plug in a 5 and a 0 and subtract. What do I need to not forget about, though? The 1/5 in the front. Okay, now I'm going to wait and do that at the very